Hello, good afternoon. I am Surendar Reddy from FX Institute of Maths and Sciences. In this video, we are going to discuss about our aspirant program. In that aspirant program, whatever the worksheets are there lesson wise, that all our worksheets and key we are going to discuss now. So first of all, we are going to discuss aspirant program 8th grade, second chapter, metals and non-metals. Complete key we are going to discuss in this video. Okay, now we come to the point. In this video, we are showing the slides, and each slide one question is there. For that question, we are going to give the answer. Okay, the first question is, which property of metals allows them to be beaten into thin sheets? So we know the property of metals. In that, main property of metals are what? Ductility, malleability, conductivity, these lustre, sonority, these all are the properties of metals. In that, one of the most common property of metal is what? Malleability. So our answer is what? Malleability. Because of what is meant by malleability? The metals are beaten into a thin sheets. The property is called what? Malleability. The malleability property is nothing but the metals on beating, they become a thin sheets. So that property is called what? Malleability. So our answer is what? Malleability. And next we go to the second slide. Among the following, which is a metal? So here four options are given. In these four options, carbon, nitrogen, sodium and oxygen. Carbon, nitrogen and oxygen are non-metals. Remaining one is what? Sodium. Sodium is the metal. It is a alkali earth metal. It is a first group element. So our option is what? Option C. That is what? Sodium. And next we go to the next slide. Which element among the following is classified as non-metal? Which element among the following is classified as a non-metal? See here, among these four options, three options are metal, only one is non-metal. We need to find out that which one is the non-metal. So zinc, aluminium and iron. Option A, B, C are the metals. Remaining one is what? Option D, that is what? Nitrogen. It is a non-metal. So our answer is option D. So it is a non-metal. And next we go to the fourth slide. All the materials display the property of malleability except for. So here four is given, four options are given. So what is saying? In these four options, all are showing the malleability except one. So which is that? So we need to find out that which one is not showing the malleability property. Generally, we know the non-metals are brittle in nature. The non-metallic elements do not showing the malleability and ductility. So in these four options, which one is the non-metallic element? We need to find out. So that non-metallic element is what? Option B. That is nothing but graphite. So graphite is generally carbon. The allotrophic, crystalline allotrophic form of carbon, that is nothing but graphite. So graphite is the non-metallic element. Okay. Now, next slide, we go to the next slide. Which one of the following is a good conductor of electricity? So here, among these four options, which one is act as a good conductor of electricity? See, just now in the first question only we discussed, metals are showing the characteristic properties like ductility, malleability, conductivity, sonority, etc. So in that, metals are generally good conductors of electricity. So in these four options, which one is the metallic element? We need to find out. So we know iron is the metallic element. So option A is option A. Option E is the metallic element. It is act as a good conductor of electricity. So here we need to raise the question again. Why the metals only act as a good conductors of electricity? Simple. Because of the metallic, if we observe the structure of metals, all the metal atoms are very closely packed together by the formation of metal bonds, while that the metal atoms are the metal atoms are generally electropositive characteristics in nature. Due to that nature, they loses the electrons and forming the positive charged ions, while that whatever the electrons are coming out from that metals, that electrons are free in nature. They are delocalizing electrons. They are freely moving in that crystal structure, metallic crystal. Okay, while that these whatever that free electrons are there in that metallic crystal, these free electrons are act as a charge carriers. They are responsible for the conduction of electricity. So that the reason why the metallic elements are act as a good conductor of electricity, because of in metallic elements, the metal atoms are losing the electrons. Whatever the electrons are coming out, that electrons are free electrons. They are act as a charge carriers. That electrons are act as a charge carriers and conduct the electricity. Okay, now we go to the next slide. What is the property of metal that allows it to be drawn into wires? That allows it to be drawn into wires. So this is also one of the property of metals. Metals are drawn into wires by application of external force on them. That property is called ductility. That property is called ductility. Metals are drawn into a wires by the application of external force on them. That property is called ductility. So why the metals are showing the ductility? Simple. When we observe the metallic crystal structure, in that metallic atoms are closely packed together by the formation of metallic bonds, while that they are losing the electrons, as just now I said. That metallic ions are sliding over one another. They slide past each other, while that delocalizing electrons, sea of electrons are freely moving in that crystal structure. So while that, when we hammered this metal, when we drawn the metal, due to the external force acting on them, that metallic atoms are changed their position, slide on each other, slide past each other, and changed their positions without breaking the crystal structure. So without breaking that metallic bond, they are changing their positions. While that whatever the positions of the metal atoms are changed, metal ions are changed, they are stabilized by the delocalized electrons. So due to this reason, metals are showing the malleability and ductility. So this is a characteristic property of metals. But malleability, ductility of all the metals are again not same. Why? Because it is again depends on the strength of metallic bond in that metallic crystal and size of the metallic atoms. These are again determines what the way they are showing that malleability and ductility, how much they are malleable in nature and ductile in nature. Okay, now we come to the next question. Metals that produce ringing sounds are referred to as. This is also one of the common property of the metals, general property of metals. Metals on beating produce a loud sound. That property is called what? Sonority, and they are sonorous in nature. So our answer is option B. Okay. Now next slide. Which metal exists in liquid state at room temperature? So here four metallic elements are given: iron, zinc, mercury and aluminum. Among these four metals, which metal is exist in liquid state at the room temperature? So among these, option C is mercury. The mercury is exist in liquid state at room temperature. Why? Because if we see the melting point of mercury, melting point of mercury is very less, that is minus 38.83 degree Celsius. This is very lowest temperature, below 0 degree Celsius. So generally room temperature is at 20 degrees and above 20 degrees Celsius. But here mercury is converting into liquid state, it is existing into liquid state at minus 38.83 degrees Celsius temperature. So that means what? At room temperature, below room temperature, at 0 degree Celsius temperature also, mercury is existing in what state? It is liquids in state. Okay, so our option is option C. Okay, now next question. The solution produced from the ash of magnesium ribbon is in dash nature. So whatever the solution produced from the ash of magnesium ribbon, it is in what nature? So generally it is in basic nature, because of we know when metals are born in air means they are reacting with oxygen, giving rise to metal oxides. Metal oxides. Metal oxides are generally basic in nature. Basic in nature. When these metallic oxides are dissolved in water, it gives rise to metal hydroxides. Metal hydroxides. Metal hydroxides are nothing but what? Base. So that means here the solution produced from the ash of magnesium ribbon is nothing but what? Metal hydroxide. It is what in nature? Basic in nature. So our answer is option B, that is basic in nature. And next question, what is the chemical formula for sulfurous acid? The chemical formula of sulfurous acid is option D. Sorry. The chemical formula of sulfuric acid is option D, H2SO3. Here two acids are there, H2SO4 and H2SO3. H2SO4 is the sulfuric acid and H2SO4 is sulfuric acid, H2SO3 is the sulfurous acid. So how can we distinguish the sulfuric acid? Okay. Anionic part suffixed with ic. Sorry, suffixed with 8. Anionic part is suffixed with 8. Suffixed with 8. The resultant acid is what? Ic acid. In a given acid molecule, if the anionic part is suffixed with the 8, the resultant acid is what? Ic acid. So your suffix is what? Ic, na? So therefore it is a sulfuric acid. Sulfuric acid. If anionic part is suffixed with the ite, anionic part is suffixed with what? Ite. Here anionic part is what? SO3. Suffixed with what? Ite. Ite. The resultant acid is contains the suffix is what? The resultant acid, whatever the acid molecule is there, it is suffixed with what? Az. Suffixed with what? Az. That is what? Az acid, nothing but sulfurous acid. Sulfurous acid. Simply we can say, generally these acids are called oxyacids. Oxyacids nothing but what? Hydrogen and oxygen, any other element is combinedly forming the acid. That acids are called oxyacids. If two oxyacids are made up of same elements, in that the amount of oxygen, whatever the amount of oxygen is there, that amount of oxygen is determines whether it is the oxyacid or acid. Sorry, whether it is a ic acid or acid. If the amount of oxygen in a given acidic molecule is more, it is a ic acid. If the amount of oxygen is comparatively less, it is called acid. For example, here hydrogen, sulfur and oxygen. Hydrogen, sulfur and oxygen. Both are having same elements in their molecular formulas. But comparatively in that H2SO4 amount of oxygen is more. Therefore, it is suffixed with ic and sulfuric acid. Here amount of oxygen is less in H2SO3. Therefore, it is suffixed with us and it is a sulfurous acid. So in two ways we can distinguish acids and ic acids. How? First method, if oxyacids are there, in that oxyacid, the anionic part is suffixed with the 8, the resultant acid is ic acid. If the anionic part is suffixed with the "ite", the acid is suffixed with "az". The resultant acid is "az" acid, nothing but sulfurous acid. In other way, in a given oxyacids, relatively the amount of oxygen is more in a acid, that acid is the ic acid, and relatively the amount of oxygen is less, that acid is called "az" acid, nothing but sulfurous acid and sulfuric acid. In this way, we can identify the acid is "az" acid or ic acid. So in this question, what is the chemical formula for the sulfurous acid is asking. Sulfurous means "az" acid. "Az" acid means in both the molecular formulas, which one is contains less number of oxygen? That is nothing but "az" acid. So H2SO4 is contains less number of oxygen, therefore it is the "az" acid. Our answer is option D. Okay, in this video we discussed the 10 questions. In next video we are going to continue 11th question to 28th question. Each video we are